Yes, sir.
Okay. So, very good morning to all of you. Very good morning, Abhi sir.
Good morning, sir.
So, now we are going to start our today's session of the orientation part and the launchpad in AR/VR. So, before moving towards our session, I want to introduce our guest, our esteemed guest, like Mr. Aviral Dwivedi. I want to give a brief introduction to our guest. Mr. Dwivedi is a strategic XR consultant and solution architect with over 12 years of experience in augmented reality, virtual reality, and AI part. Apart from that, he is the founder of free product company, then XRDI, Extended Reality Developers of India. These are the he is the founder of this most important company in the virtual reality and augmented reality, where he has leads to efforts for the XR, AR, and the VR. From 12 years, he is educating more than 10,000 students, and he is collaborating with he's a community. He's accessing a community of with more than 3,500 people over there, and they are educating the 10,000 plus students in the field of AR and the VR. So it's our honor to have you here, sir. We are very much glad to have you here, and he's conducting more. Apart means lots of workshops, seminars for the colleges, for the university, and for the education purpose. And the most important part for education purpose, he doesn't charge anything. Am I right, sir?
Yes, sir. Thanks
Yes,
for
sir.
this wonderful introduction.
So for now, we are honored, Mr. Dwivedi, for joining us today. We look forward for gaining insight what the future of AR VR. Those students has joined the Center of Excellence. I feel very much gratitude means feel very much privileged that this kind of personality is here to launch our Center of Excellence of Augmented Reality and Virtual Reality. Sir, before moving towards your session, I want to play one short clip regarding the Center of Excellence. If you permit, so I can play it.
Sure, sir.
Yes. Sir, I have shared my screen. My screen. You can also see that. Okay, sir. So this is the short video clip regarding the Center of Excellence brief. What is the mission? vision and the objective of establishing what is the objective behind the establishing of Center of Excellence, Augmented and Virtual Reality. So for now, over to you, Avi sir.
Sharing my screen, and
Yes,
then
yes,
we'll
yes.
look into the slides. And how it's gonna go is basically I've sent the share request, and we're gonna first talk about look at the screens, and what I'm talking about today is how virtual reality basically works and what is virtual reality at the first place. We're gonna look at very small stats as well. Usually I do a very large stat, but we'll look at some of the stats as well. And then finally we're gonna go towards ask me anything session, where you can also craft your question, and whatever you have in mind about virtual reality, you can kind of ask that as well. So is my screen sharing now? Yeah.
Yes, yes.
Okay, I'm starting to share.
Yes, yes.
Okay, is it still visible there?
Yes, sir. Screen is visible.
Okay, so let's do this. Let's dive into what we're gonna do today. Today we're gonna talk about extended reality, and extended reality, what it is, and what we are doing here. So extended reality is basically an umbrella term. It means it has consist of all these other terms like virtual reality, augmented reality, mixed reality, and there is something called cinematic reality, which is VFX and movies, how these are made. So all of these are kind of a part of this group called extended reality. Here, the X in the extended reality is kind of a variable. You can switch it with any like VAR, anything. You can switch it with that, and it becomes one more element into this reality realm. So that's what extended reality kind of is. Okay, so a brief introduction. Vidurji has already given such a beautiful introduction to me, but I'll give it once more. So I'm Avi, and I am into this space of virtual reality and augmented reality for past 12 years. I have been a medical imaging scientist, worked in the surgical robotic innovation space, and of course I have done a lot of podcasts within this same space of virtual reality. And I also make AI ads for a couple of brands, and of course a couple of virtual reality work. So some of you might have seen me at Shark Tank season 4. So yeah, I have done 120 plus community workshops so far, and this is again one of those. So as Viduji has already said, that I never charge for these workshops, because I think education should be accessible and available to everyone within best quality. So if I talk about myself, I have studied. I mean, on document, I have studied from Lucknow University and Lucknow. There's a college in Lucknow, but if you genuinely ask me, I have studied from MIT, I have studied from Stanford, all these colleges, because all of those has very good quality of courses available online where you can also learn. So I sometimes studying classes from MIT, studying classes for Stanford, and all of these are really amazing lectures where you can also subscribe to these courses and start learning. So yeah, this is one of the grand events that I have attended, and great amount of people which I got chance to meet uh, within my journey. Most of my work has been into the healthcare space, and why am I at the last slide? Okay, too far. क्विक रिकैप मिल जाएगा इसमें सारी स्लाइड्स का. Okay, so we were at this slide. All right. So this is the Shark Tank episode where I was there. This is me. उस समय I gained a lot of weight. So yeah. Then this is again me. I have interviewed for NDTV and of course couple of other news channels as well, talking about the things that I have built for a couple of other companies. And he is ISRO's ex-director. He is also known as the Moon Man of India. He is Dr. Anna Adurai. So talking about virtual reality, these are old stats which I am presenting you. By a report by Accenture suggests that $160 billion by 2023, which is true because Meta has put a lot of money into this. These are huge stack of companies working into the space of virtual reality. And then the estimated market size of virtual reality by PwC report was 1.5 trillion. And 1.5 trillion is a huge number. It's almost half of our current economy. Okay, so let's talk about what is extended reality, and let's just talk a little, go a little deeper. So you might have heard of digital and might have heard of this word called digital. So what is digital exactly and what is virtual exactly? And if there is digital, why there is another world which is virtual? Okay, so because we're gonna dive into virtual reality, we have to first understand what virtual at the first place. So to my research, when I studied this, I was wondering that why there are two words, and I realized that everything that is made up of digits. What are digits? Binary, zeros and ones. So everything that is made up of digits is called digital, kind of. And what is virtual? So anything that is meant to be understood by human, it's called virtual. So it's again digital, but the form of data which is digital but meant to be understood by humans. I'll give you an example of that. So if you go on a folder, any computer folder, take a MP3 file or any other format file, right click on it and click it on open to notepad. Okay, and the file should be like an image file, or file should be like I'd say an MP3 file. And what you'll realize, it will on a notepad, it's written gibberish. So what it's trying to give you is basically the 0 to 1 code, which is a binary code converted to ASCII code and then written on that notepad. So it's not meant to be open with notepad, but if you still forcing it to be open on notepad, it's showing you that gibberish. Now that gibberish data is digital because it's not meant to be understood by human. How it becomes virtual? When you open it on the correct format, on the correct layer of that particular data, and now it's meant to be understood by human. So for example, the slide you are looking at right now, it's not a digital slide, it's a virtual slide. It will become digital when it's being transmitted from one point of the space to another point of the space. For example, from my computer to your computer via a network. So the digits that are meant to be understood by the computers is digital, and then when we use some screens or some visual format to represent data, that then it becomes virtual. So that should be a clear definition between those. Then what is virtual simulation? So when we start crafting these virtual bits of data and start creating a simulation around ourselves, so it becomes virtual simulations. For example, we saw something in the real world. For example, it's raining in the real world, and you decide to showcase that real world rain into a virtual environment. You decide to replicate that or model that into a virtual world. Okay, So then it becomes a virtual simulation because you have seen a physical phenomena happening in the real world, and then you replicate into a virtual space. Okay, so that's something called virtual simulation. You saw a train moving on the tracks in the real world, and you decide that, okay, I want to see this on my computer. So when you simulate that, craft that into this virtual world, it becomes virtual simulation. What is virtual reality then? Virtual reality is nothing but when you put a human inside this virtual world. How do you put a human inside that virtual world is another question. So basically, we try to hack the human senses. What senses do we have? We have eyes, ears, touch. We have a sense of smell. We can hack all of these senses using technology and feed those input data with some fake data, or you can say artificial data. Okay, so when we hack your eyes using, let's say, monitors or screen or displays, and then we hack your ears with small speakers, and then we hack your touch sensation with something called haptic, or we can also cover your smell sensations as well. There are some fake smell sensation producers as well. Okay, so all of these things are part of this virtual reality group, where the ideal goal is to kind of hack as much senses as possible. Okay, so that's particular thing is called virtual reality. Then you might ask, what is augmented reality? Augmented reality is something different, where the goal is not to put a human inside virtual world, but other way around. Take something from the virtual world and get it into the real world. Okay, so for example, Instagram may you have all those filters. So whenever you saw a filter, for example, bunny ears, you are bringing out a virtual element, pasting on the real world. So that becomes augmented reality. The definition is very clear between these two. In virtual reality, the goal is to submerge some real human inside a virtual world in such a way that he feels that, okay, this is something real, right? And in augmented reality, you are bringing out some of the elements of those virtual world, not necessarily the entire virtual world, but that could be too, right? And then you bring that into the reality, and it becomes augmented reality. Mixed reality again is a mix of both. So this particular term was popularized by Microsoft in 2015 when they launched their HoloLens devices. So it was head-held augmented reality. So earlier the augmented reality was mostly popular as handheld augmented reality, where you are using a phone in your hand, and the phone camera was capturing the reality of the world, the real world, and then augmented reality is pasted and visible on the phone. But HoloLens start using this head-held augmented reality, where you don't have to hold anything and everything was in front of you. Okay, so that becomes mixed reality somewhere. So HMD is the main element what makes mixed reality. Next, we have virtual haptics. So as I said, the ideal goal is to surround or hack every sensation with and feed it with some artificial data. So you have all those five senses. One of them is touch. So haptic is basically when we try to simulate the touch sensation. So touch sensation could be in several ways. It could be a push as well. It could be a sensation of, let's say, softer touch or harder touch, or let's say a pinch. So all of these the goal is to have some robotics in such a way, use some robotics or vibration sensors in some places as a way that it simulates some touch events, some sensational events. Okay, then we have spatial audio. We all have 5.1 channel sounds in our home. So that's spatial audio. Basically, the idea is to if a subject is talking from the left, I should feel that subject is talking from the left. If a subject is talking from behind, I should be able to locate that subject is behind my head. Okay, so जिन लोगों ने CSGO खेला है, उन लोगों को पता होगा what is spatial audio. जब आपके पीछे से कोई स्नाइपर आ रहा होता है या जो भी बंदा आ रहा होता है, you are easily able to locate that where they are coming from. from their footstep or something, right? So that's spatial audio. Then there is location based XR. What is it means basically, uh, whatever location at you are, how we can gamify that and use that in our leverage to kind of simulate something. So that's location based XR. So biggest example of that is Google Maps, of course, and then another one is Pokemon Go. So Pokemon Go was a very popular game in 2014, I would say. It came and became very popular, a global hit game. Still people playing that, and there were big tournaments in this. The company behind that is called Niantic, and Niantic became the biggest augmented reality map provider because of that game. So that's a whole story. So then there is a concept of metaverse. This is Republic Day 2022 in India as well. We our community was part of this, bringing this jhaki at Republic Day parade. So we wanted to educate India about what is metaverse. So we gave FISI and all those other government bodies this concept कि हम ये झांकी कर सकते हैं. And we planned, me and one more people from our team and some IT professors grouped together and said ki this should be something, and then we talked about this, and this was happened. So this is what metaverse is. Metaverse is basically not one entity, I would say. It's a collection of it's a replica of a world. Every world could have their own rules. It's like a small universe called metaverse, where everything is virtual and people can connect within that virtual space from all around the world. So no matter if you are living in Maharashtra or Gujarat or Canada, you can connect from anywhere in the world. When you connect into one metaverse room, you are inside that one room regardless of the physical space. You can share the experiences together, which means if a dinosaur appears in front of you, your friend will be able to see that as well from the same perspective as like positions from the there. Okay, so there is a metaverse called Sansar. So all of these metaverses are trying to replicate world, but with their own twists and turns, with their own graphics, with their own rules. So it's very fantastic place. If somebody has seen Ready Player Me, he know what metaverses are. Okay, so all of these metaverses have their own rules. Okay, so in these metaverses there have been a lot of grand concerts, and one of them is Ariana Grande's concert and Travis Scott's concert. So these big concerts have happened in this. I have attended a Pitbull concert. So a couple of these concerts were happening within the metaverse space. Especially in the year 2020, it was like super hyped. So yeah, that gave proof of concept to everyone. So I'll give you an example.
तो आई गेस हमें जो आपने ये पूरा सेटअप इन्वायरमेंट क्रिएट किया है तो हम अपने व्यूअर्स को एक बार दिखा सकते हैं.
Is the audio there?
राइट?
Is the audio for this video there? Yeah. Okay. Okay. So this is again an example of metaverse, where me and one of my friend from Canada are joining together with this virtual space. And I'll want to take you to the favorite part of mine within this. Yeah. So my friend is a great fan of Captain America. So I have given him this Captain America costume for trial.
आप पहुंच पाओगे?
So he can
इक्विप पे उंगली दिखा के क्लिक कर दो. ओहो, कैप्टन अमेरिका.
Okay, so he got that Captain America kind of.
तो ये देखो मेरा आयरन मैन सूट. एक काम करता हूँ, इसका अच्छा वीडियो बनाता हूँ. ये जगह हमने थोड़ी टेढ़ी कर दी. कोई नहीं. वैसे भी एवेंजर्स हो रखा है.
Okay, so we taken selfies regardless of like distances between us. We were able to kind of shoot this thing, and we have those selfies and everything was going on. So such things are possible with the help of metaverses. Regardless of space, you can connect with anyone, have meetings, and there is another one which I'll show here. Okay, so it's a six like year old was deceased, and her mother replicated her for a Korean TV show. So this was one of the episode in there, like Black Mirror. It has one of the episode in there in which her daughter was recreated using virtual reality. She is wearing all those haptic gloves, as I said in the beginning, so through which she can spend one more day with her deceased daughter and kind of celebrate some more moments with her. Using those haptic gloves, she can touch her again, feel her again, maybe sing a few more lullabies. So that's another use of metaverses. Then there are weddings that are happening within metaverses. So in fact, I was part of one of the wedding as well. There's a very popular YouTube creator, European. She got married, and she has a very big community. So we were all invited at her wedding. So these are the weddings which are happening in the metaverses, and it's phenomenal to see. Then there is yeah this is something which you can try as well. This might not work for every phone, but this might work for some phones. Okay, because the sensors that are required to kind of make this happen are with very few phones. So you can use your phone, scan this QR here, and then look at this image. And when you do that, you will be able to see an augmented reality example. Okay, so scan that, and there will be an allow thing. So allow that, and then look at this image. So then you will be able to see a small robot, and that robot will be playing with some virtual objects, and then you can kind of rotate and things like that based on your convenience. Okay, so that's one, and I'm moving to next slide. Okay, so these are a couple of things that we have.
Alright guys, so we are going to try this XRDI Instagram filter. So tap on the screen like this, and now it's lit, and happy birthday! Yay! So that's how you celebrate XRDI.
Okay, I accidentally clicked on the link. Get back. Okay, then we have now I want to dive a little technical into what metaverses are. So you guys might have remembered this scene from the Matrix, where this small monk tell Neo that there is no spoon, that's why I'm able to bend him. Okay, so this is what is true with the metaverses as well. No matter how real these words feel, no matter how immersive they feel, and no matter how like believable everything looks within them, you can do all the superhero things within metaverses just because there is no such thing as a 3D model. Okay, there is whatever you see inside that can be crafted, and after this like slides, this couple of slides, you're gonna believe that you can build anything within metaverses, because there is nothing real within metaverses. Okay, so This next session is inspired. Next slides are inspired by again Stanford's CS50. So let's go. So if I ask you guys that what is this 1 2 3, so you guys gonna say 123. Okay, so when you are saying this is 123, you are coming to this conclusion that's one is at the first place, 2 is at the 10th place, and 1 is again at the 100th place. Okay, so that's how we come up with this 123, and then you sum all of those up, है ना? So this is something called our system, which is called decimal power system, right? Or base 10 power system. We have studied this, right? So this is base 10 power system, जिसमें this is at 1th place, this is at 10th place, and this is at 100th place. This one is 30 times bigger than this 3. However, 1 should be smaller than 3, isn't it? So that's how the decimal system works. You have this base, which is, this is a base 10 system, which means in each letter there could be 10 digits. Okay, not less than 10, not more than 10, there could be 10 digits, right? And then each digit is going to like raise like this to the 10th power. Okay, so that's how the decimal system is begun. So that's how, when I ask you what is this, you guys said 123, because you have this calculation running in your mind by itself. It's very easy to, and we have grown up with this system, decimal number system. That's why we understand what is 123. Okay, we did all those calculations within our heads and said 123. All right. So but for machines this is harder to understand. Why? Because decimal number system has values 0 to 9. Okay, 10 values. So a machine, if had to operate with this number system, had to kind of work with 10 values, 10 digital knobs or 10 knobs. Okay, state machine keeper which deals with 10 states. Okay, which was very hard to build, and even if built, it's very hard to optimize, and even if optimize, it very hard to scale, right? So these are the challenges when we are working with decimal. That's why we don't work with decimal when it comes to computers. We worked with something called binary, which has just 2 states, either on or off, 0 or 1. Okay, so this is somehow better for computers. So how do you represent this? So this is a base 2 system. So the first place has 2 to the power 0, second 2 to the power 1, third place has 2 to the power 2, which becomes 0 means 1. Okay, and then this has the maximum value of 2, this has the maximum value of 4. Okay, so if this bit is on, we will count it as 4. Okay, if this bit is on, we'll count it as 2. If this bit is off, we'll count it as 0. If bit is on, we'll count it as 1. If this bit is off, we'll count it as 0. If on, we'll count it as 2. Okay, very simple. And then we do all the calculation at the total is 6. So if there is 110, it's not 110, it's 6. Okay, so that's the binary number system. So that's how we represent all the numbers, all the mathematics within computers. But then you gonna ask me, or you should be curious about, how do we represent all the letters, characters, my name, how that goes into the computer. Okay, so because as I said, machine only understands zeros and ones, so how characters, how letters? So then we'll say that we have to come up with a map. Okay, so this is the map, this is how it looks like. So we built a map, and this map is called ASCII systems. Okay, then there are many other maps as well, but this is the most popular one, and this is the one you are most familiar with. We kept this A at 65, and till 90 there is Z. So all of the characters are mapped. Okay, when I have to write my name, my name Avi is going to be A65 then V is 86, and then I is going to be 73. Okay, so if I have to say my name within binary, I'll say 65, then I'll say 86, then I'll say this 73, and that will become my name. And of course, I don't say those number, I'll convert it back to binary. Okay, so which means this A is this thing. If you convert it, sort it back, it will become 65. Okay, so that's how the binary represents characters. Then you will say we have some more things to represent. Okay, my internet connection says it's unstable, so it's better to I switch to the hotspot. Just give me a second. Okay, I'm switching to the mobile connection for yeah, I switched to this mobile connection for better connectivity. I hope it's not interrupting now.
Yes, sir.
All right. So we were talking about this. We have talked about this map, and you guys understood it. Now, if I have to write a message, I'll go back to the map, and H is 72, I is 73, and this exclamation mark is 33. And then you will say, then there are some more things. If a message is sent, these three numbers are sent which are correct, but then there are some things called emojis, and Gen Z's love emojis. So how Gen Z gonna communicate without emojis? Okay, so when talking about emojis, I'll give you one more fact which I came to know, that this exact phrase, this 72, 73, and 33 converts into a color. So if you convert it into a color, I'll tell you how to convert it into a color later. But then it becomes the color yellow, and exact this yellow which is used in emojis. Okay, so this high phrase is why all the emojis are yellow. So why all the emojis are yellow got from the fact high. So they use this color because of the word high, because high is basically how you communicate. Okay, so talking about emojis, how do you make emojis? Emojis are pictures. You know now how to represent numbers, you know how to represent letters, but how do we represent pictures? For easy pictures, we have this bigger numbers which represent emojis, a map, a separate map which represent all those characters, symbols, emojis, all of those has maps. So it's beyond ASCII, but there are other maps as well. Okay, and as I said, there is, you can represent this with with color as well. So how do you represent color? Is basically RGB, and HSV is also there, but HSV is for a different purpose, but then RGB is very straightforward. So human eye has this three color detector cones called red, green, and blue, and all the colors we see are coming from excitation of these cones. So when we talk about RGB, so we can represent many millions of colors using those three combinations. So RGB represent a color, but a single color. Then how do we represent a kind of an image? The answer is array of color. Okay, so this is a gray color picture. We called it a monochrome picture. Okay, because it has only one color, one range of color. So 0 to 255 color is ranged, and 0 means a very dark pixel. So wherever you will see 5, so 5 is a very dark pixel. Okay, and then the higher numbers becomes a white pixel. So 256 is the max range. Here we can see 252. So it's a very bright pixel. Here is 256, very bright pixel. Okay, so dark pixel and bright pixels create images. So it's a very blurry image because we are using less amount of pixels, but this is Abraham Lincoln image. Okay, then you will say how to make videos. Okay, there are videos. So this is a video, and in fact this is world's first video. So there was no such thing as video before this horse riding. This is world's first video, and how it's the name of it is horse in motion, and how it's made by these stacking up these images, these 12 images. So the when the creator was creating, he realized that you at least need 12 images to create a sense of motion. If less than that, we'll find it very jerky, and so on. Now let's talk about what is an algorithm, and why we are talking about this. I'm telling you. So there in computers work with something called algorithm. Okay, now earlier we understood how computer represent numbers, then we understood how they represent colors, then we understood how they represent characters, letters, then images, then videos. We understood all of this. Okay, there is some more technical details, but to for your understanding, I'm just proving there is no such thing as a video or an image. It's all just collection of numbers, and if there is numbers, you can change those number and create anything you want. Okay, so just giving you a belief. So what is algorithm? Algorithm is basically just an input and an output. In between there is something happening, and whatever happening is called algorithm. Okay, so a fixed set of rules crafted towards a fixed set of I would say output, intended output, is called algorithm. Okay, so this could be anything, and there is a certain kind of algorithm called render algorithm. Okay, and the goal and purpose of render algorithm is basically create an image. You know what is an image? Image is basically this random collection of numbers. Okay, so when I say rendering algorithm, the rendering algorithm, what it is doing, it is dropping these number at correct positions. It is dropping this 157 to this 1 to 75. So algorithm, a rendering algorithm, what it's gonna do is basically create a 2D array. You can call it an array. Okay, a 2D list of numbers, and fill in those numbers exactly like this. Okay, and when these numbers gonna be converted into the colors, it will become a picture. Okay, so an algorithm, specifically rendering algorithm, converts all those data, all those code into a visual image. That's what rendering is basically. Okay, from code to a visual image is called rendering. Okay, and how do we define what to draw? How do you define which pixel has to be dark, which pixel has to be white? Is mostly controlled using this. So this is basically something called mesh. Okay, whenever you have to define a shape inside a rendering algorithm, let's say I have an object and I have to define its shape in those rendering algorithm. In that case, I have to point at that shape, and I am gonna point that where is my v0, yani vertex 0. Each individual point in this shape is gonna be called a vertex. So where is this vertex 0, where is this vertex 2, where is this vertex 3? So that's how in space mathematically I'm defining where is my point 0, where is my point 2. And space I'm assuming is a 3D space, a mathematical 3D space, where we are assuming all of these things happening. Okay, so that's how we drop all those numbers. So when we say we define a shape, what we exactly do, we drop all these numbers, v0 0 0 0, v1 1 0 0. So this is the simplest object that you can create. Okay, so that's how we kind of created all the this cube. Okay, then what rendering algorithm gonna do? Rendering algorithm gonna render this cube. All right, so it's gonna first do vertex processing. Vertex processing basically means read all those numbers. Okay, then rasterization. Rasterization basically means where those numbers fall in this particular space based on their number position. So if I have to map it on 3D space, 3D to 2D I would say, then rasterization works. Then fragment processing, then this output merging. Fragment processing is basically the filling in the color between each space. So let's say v1 to v2, and that has to be v1 is red and v2 is blue. So this line, this fragment processor gonna fill in the color between red to blue within this space. Okay, so the very purpose is of this algorithm is basically create an image. And you know what is an image? Image is basically a set of collection of numbers. So it fills in all those numbers at correct position, correct way. Got it? And don't just worry and don't get disappointed, because you don't have to do it manually. You don't have to write an algorithm to write all those numbers, because even if you're gonna do for one single cube, it's complicated. I have created cubes, I have created procedural geometry, and it's extremely complicated stuff. Okay, so to help those complications, we have these 3D tools, and these 3D tools are called Max, Maya, ZBrush, Blender, and there are plenty of more. Okay, so what they basically do, they allow you, they give you a 3D perspective, a 3D space where you can easily put those points. Each vertex you can put it very precisely, very correctly, and these softwares are designed to help you put those numbers in precision. So of course, in manually, if you want, you're gonna go and put V7, and V7 has this very weird number 011. So how you gonna come up with 0 number 11 is basically mapping out this 3D space. But you this software gonna allow you to visualize that 3D space, and you can put all those numbers very correctly. Got it so far? So next we have this tools which are very known for real-time rendering. Okay, what is the difference between these tools and this tool? This next tool is basically real-time rendering and not. Okay, so just 1 second, I was recording this session and my screen got switched. Okay, yeah, that's fine. Screen recording, yeah, here it is. Okay, so difference between Max, Maya, Blender versus Unreal and Unity, they are more responsible for real-time rendering, which means every image you're gonna see is created just now. Okay, so they look at the 3D space which you created from a point which is called a viewpoint. Okay, which also you can say camera, and camera is modeled after a real world camera, so it has all the properties of a real world camera. It is a representation of that real world camera, or you can also say an eye. So when some objects are there, it renders them. Renders basically means creating image, and creating image basically means pulling out all those numbers and array. So still we are still dealing with binary, everything is binary. Now you're gonna say, where is depth? We have often talked about 3D, and the 3D means depth, but still अभी हमारा Unity जो चीज़ें create कर रहा है, that everything which Unity has created is 2D. So how the depth comes from, where the depth is coming, how to see depth. So that's what I have added here. So if you, how you perceive naturally depth is with two kind of eyes. Okay, so when you look at some object, this C and B object, okay, your left eye is gonna see the C perspective more and B perspective less, and your right eye is gonna see the B perspective more and C perspective less. Okay, so both eye are rendering a different image. Okay, but what your brain is gonna do is gonna compute between those two images and create a sense of depth. All right, so depth comes from two images coming together. So basically, if I have to experience depth within a human, I can hack those two eyes and give different images from different perspective, and person will feel that there is something called depth, but there is no depth. Okay, so there is this image belongs to 1838 device. It's an old device which used to be used there, and there is an image. You can see left image and right image is very similar, but both these images are drawn from a perspective which is just a distance apart, which is called IPD distance apart. Okay, when you look from here, it appears as 3D. Okay, because the depth, illusion of depth emerges. Similarly, you might have gone to a 3D movie show, and why they give you these glasses is basically they can filter the content which goes to your left eye and the right eye. So these are traditional glasses. There is a blue filter and red filter, and the lighting is also, the image is also on the screen is color coded with the left eye, let's say blue, or right eye, let's say this uh, uh, red filter. Okay, so all the red eye is eliminated with this red filter, and only the blue eye passes in this eye. Okay, similarly, all the blue light is filtered by this blue filter, and only the red eyes goes to this eye. Okay, only the red light goes to this eye. So you create or you receive basically different images in your both eyes, and that's how you perceive depth. And these are the new glasses. These are called active shutter. So there's an shutter which is shutting this eye, then this eye, so fast that you never feel it, and that's how you create depth. And to capture depth also, there are these 3D cameras which has, you can see, two sensors creating images from a perspective, like capturing from two eyes. So that's how the depth works. Similarly, you have immersive 3D, and these are the cameras which are used for immersive 3Ds. These capture the images from all the surroundings. We call them fisheye lenses, and they capture the surrounding. Okay, an example of this is here. So if I play this, it's a Nat Geo film. So if I play this, I am with some loins, but I can also see what's around.
To lead her cub away from the pride, but it happens.
I can look up as well. I can look down as well. So I can go anywhere within this range where I want. So how this is captured? Using a lens which is called fisheye lens, and that captures 360. So that basically has multiple lenses, and then image is being stitched. All right. So something like this. This is called volumetric capture, in which all the cameras are around the subject. So let's say there is a subject in between, and then there is a circular motion setup. Okay, all the cameras are capturing different perspective of the image and then reconstruct that into a model. Okay, so that's how basically it's captured. Through this year, if this is not a history session, but within history session I talk about all of these devices in detail. So basically there have been these devices throughout which have worked on 3D, or I would say virtual reality. So this is the history of VR, and right now these are the most popular hardware, I would say, on the planet for using virtual reality, and these are the most popular softwares when you are working in the space of virtual reality. I'll share the slide so you guys can take a look. This is my community called XRDI, and I share a lot of virtual reality content with the people. So here you're gonna find very relevant videos. There are podcasts of industry experts. I have shot more than 70 podcasts with top leaders in the virtual reality space. And yeah, there are 2 seasons of that, so you can kind of watch them at your will. Once at a time, I used to have this a job portal which was India's only virtual reality job portal, and it was making very easy to find virtual reality jobs for people. But for some financial reasons, I was not able to continue with this. But this was India's only job portal which I kind of created for helping virtual reality community, bridging the connection between students like you and the companies which are recruiting talent like you. So yeah, this is not working now, but I am collecting money, and as soon as I'll be able to get some more money, because this was funded just by me, so it has some limitations. But yeah, it was very good at till it was operating. It was very good, and India's only platform within this space. Okay, so I think yeah, this that's it. You can scan and connect with me on these platforms. So yeah, now let's for ask for me anything. You whatever the questions you have. I hope I was able to break the illusion of complexity for you guys, the illusion of something possible within virtual reality and something not, because everything is just numbers, everything is just written on binary. So there is no limitation on what you can do or what you cannot do within virtual reality, because everything is possible. You just have to make sure it is in the correct optimized limit and it will work with virtual reality. So yeah, any questions are there?
Yes, sir. Thank you for the session, sir.
Thank you, sir.
And is there anyone who have a question?
And does not have to be a very formal question. If you have a curiosity related any movie where they have shown virtual reality, a Black Mirror episode or anything, whatever you have, just feel free to speak through, right?
Hello, sir. My name is Kajal Khatta. So my question is that what is the actual difference between the multiverse and virtual reality?
Okay, multiverse is basically uh, do you mean multiverse or do you mean metaverse?
Like multiverse.
Multiverse, okay. Multiverse is basically a physical phenomena, and the metaverse is basically a virtual phenomena. So multiverse exists in theory, but we don't have a proof to kind of prove it that it is real or not. We neither can deny the existence of multiverse or neither can prove the existence of multiverse, because it's beyond our universe. Our all the equipments that we can build to test it are within this universe, but we have a theory which suggests that there could be other universes. Okay, when you create something called light cones within Einstein's relativity theory, so there is time cones which you create, and beyond 45 degrees of those time cones there are multiverses that pops up. Okay, so that is multiverse, which means a universe which is beyond our universe, beyond our reach, beyond our equipments to sense that. So that is multiverse. That's a science fiction concept that could be true or cannot be true, but we cannot say for sure. Okay, we don't have a way to test it. We yet cannot devise something that can prove or deny the existence of multiverse, but there could be. Okay, and the metaverse, or you would say virtual reality, is basically does exist, and here you can build your own world. For example, it based on those virtual phenomena. So let's say if I really like my cat, so I can create a model of my cat within those virtual reality system, okay, or the metaverse, and can play with my cat all the time. Okay, so that's a replica of what I want. If I want to build aliens, of course I have not seen aliens, but I have the concept of aliens, which means they will live on some other planet, they'll speak some different language, they'll look different, so I can craft them within those metaverses and then kind of have a meeting with them. So these are totally artificially created metaverse, and the multiverse is basically a physical world which is beyond ours.
Thank you, sir. But can I ask you one technical question, please?
Please go ahead.
So when we wear a VR headset, so according to the presence of a person in virtual reality, how can it adjust the screen of that headset?
Can you repeat that again?
So when we wear headsets of VR, so in virtual reality, how can it adjust the screen of a presence or the person is actual is in the virtual reality?
The question is how the virtual reality headsets recognizes your presence within the world. Is that the question?
Yeah, adjust their screen according to the movements and
Got it, got it, got it, got it. So okay, so it's two sensors which kind of does that. So everything which is happening within your headset is a result of some sensors. Okay, and sensors basically are devices that takes a physical signal and convert it into an electrical signal. So that is called sensor, at least in electronics, right? So one sensor of that is basically is when you will look at your headset, inside the headsets above those I'll show you here. I have a headset. So if I open this, so there is one small sensor above this here. Okay, so this is called proximity sensor. Okay, so whenever you wear your headset, the proximity sensor lightens up. It basically do just one thing, that if light is reaching to this sensor or not. So when you wear it, which means light is not reaching to this sensors, and it lit up the screen. So these screens are lit up when the light is not reaching to this is proximity sensor. Okay, so that is one sensor. Another sensor, how it adjusts its view based on your motion, is basically a collection of sensors. There is, as you can see in this headset as well, there are multiple cameras here. Okay, if I show, there is a camera. Okay, it's blurring. There is one camera, there is one camera, there is one camera, there is one camera. So there is an algorithm called SLAM. SLAM means simultaneous localization and mapping. Yeah, can you say that again?
सर आप मतलब जो आप दिखा रहे हो वो अभी मतलब विजिबल है
विजिबल
मतलब हमें विजिबल है
अच्छा, आपको नहीं दिख रहा है वो? एक सेकंड, मैं स्क्रीन शेयर ऑफ कर देता हूँ.
सर
विजिबल नाउ?
सर विजिट जो हेडसेट बता रहे हो,
हाँ,
इट इज कंप्लीटली विजिबल एंड द सेंसर आल्सो. In fact, sir, I also have the MetaQuest Pro headset in my hand.
हाँ.
You can see that.
हाँ.
So I'm just handing over to the Kajal.
Yeah,
So
this has the cameras, as you can see. Okay, so there is an algorithm called SLAM. So when you move your headset up and down, the camera looks at the world. The world has some interest point, and those interest point moves up. So if I move the camera down, the interest point will move up from its perspective. Okay, and then it will adjust its algorithm and it will say, okay, I'm moving down because my interest points are moving up. Okay, so it does this reverse calculation, and all of those cameras does. Okay, so all of those cameras adjust its local understanding based on something called SLAM. And then there is DTC and some other algorithms as well on top of SLAM, which are much faster to run on those processors. So these algorithms basically create something called inside out tracking. Okay, so in newer headsets we have inside out tracking, which means the headset itself has the trackers and is tracking inside out. And then there is other tracking, older tracking versions which used to be there, which used to call outside in tracking, in which a station or kind of a receiver is there in somewhere in the room, and that receiver looks where the headset is in the room. Okay, so here is the receiver, here is the headset, it looks at, and when it moves anywhere in this world, it localizes it. Okay, so that's how it basically the scene is getting adjusted. The scene basically try to track the motion of the headset and readjusts itself, re-renders itself. It renders roughly 60 to 90 frames per second, which means in 1 second your view is revised 60 to 90 times. Okay, and when I say the view is again the image is again the numbers is again coming from ASCII and binary. So all of this is kind of related.
Okay. Any more questions?
Sir, are NFTs dead or still in the market?
So NFTs are never meant to be very big. It's not such a concept that could have been big. I have never kind of supported too much NFTs. However, I had to speak on NFTs earlier because it was a major part of excitement. So basically, it's a good concept. It's not like it's a bad concept, but when traders step into some concept, any concept, let's say even the blockchains right now, when trading starts happening and there is a lot of money being involved into something, then people lose their mind, and then they imagining things which are never there or never possible within the practical span, because they're thinking from the perspective of getting more money. So money kind of corrupts people's brain to think correctly. So that's what happened with NFTs is basically non-fungible tokens, which means there are things that are have values, a defined value, and then there are things that you cannot put a price on. Okay, so for example, a shoe has a value of, let's say, 3000 rupees. I have a Nike shoe which has roughly 3000 rupees. But if that shoe was also worn by, let's say, Shah Rukh Khan at one shoot, okay, and then he takes off that shoes and says ki abhi yaar tum rakh lo, okay, so then to me that shoe is not 3000 rupees anymore, because that shoe reminds me the memory of Shah Rukh Khan. So what is the now the cost of that shoe? Okay, is it $3000? Is it $30,000? $3 lakh? In how much? I would say I'll leave the possession of this shoe to the next person, transfer that possession. So that's the non-fungibility, which means it's not a fixed price. It's a price which is above the perceived value, but that is very local now. That is for me. The other person who's gonna own that gonna require all of the proof that where's the video when Shah Rukh wore that shoe or things like that, right? So after that, it will become some fun value for him. All right, so that's what NFT was trying to do, basically relate some value to the things which are invaluable, and that never became very successful because they tried to do it just with images. Okay, so just taking a picture of that shoe now and then trying to sell that picture, so that was never supposed to work.
Okay, sir. So what's the name of your cat?
What's the name of
Your cat?
my cat? Cat, right?
Yes, sir.
काजू. I have 22 cats. So अभी जो आया था उसका नाम काजू है. वेट, होगा यहीं कहीं. हाँ, यहाँ पे रुको दिखाता हूँ. ही इज काजू. काजू अभी 5 साल का है एंड बहुत प्यारा बच्चा है.
Your DP is also with cat. Is sorry, not for cat, with Kaju.
Okay,
So one more question.
sure.
Sir, AR/VR can manipulate images by smart contact lens.
Okay. So there was a company called Mojo Vision. Okay, smart contact lens. They were making very small lenses for eye to be applied just on eye. Okay, within virtual reality. Again, the biggest challenge of such technology, it's already for example the headset you had in your hand, it's already much more powerful than a laptop that you can buy around the same range. Okay, because the graphic processor and the graphic requires for it to power all the visuals are much more the intensity. As you can see, I have told you the numbers, the algorithm that requires to run it requires a lot of computing. Since it requires a lot of computing, it requires a lot of battery, and battery is heavy. Okay, anyone who has a power bank know कि battery heavy hota hai. Okay, so first you require a lot of computing, then you require a lot of battery power to kind of sustain good life of usage. So all of these technologies become bulky, heavy. So people all around the world are working to kind of make this technology lighter and still run longer, which is a major challenge. There are solutions which are being proposed. For example, separating the computing unit from the transmitting or the display unit. So such kind of experiments are being going on for many years within this space. Okay, so yeah, and as you said, the lenses that could transmit holographic projections within your eyes are true. There are being POCs, but again, they all are limited because, as I told you, the batteries are heavy. So if I have to pack a big amount of battery on, let's say, just a lens, that's very critical task. And after doing that, how many pixels it can run, that's also a critical task. So there are some complications, but again, how it basically made is basically to do a lot of trade-offs. So whatever the limits we can achieve, we try to pack it in a unit and try to test it with the market if this is something useful.
Okay, sir. Thank you. Sir, one more question.
Sure.
Hello, sir.
Hello.
The term which you mentioned, virtual haptic. Sorry, there is a special audio term. In the games, we feel that the sound is coming from right side, some left side, the sensation. How it the audio works?
Okay, it's relatively easy if you think of, if you have two speakers, okay, left and right. So there is an algorithm, I forget the name of that particular algorithm because there are algorithm for everything. Okay, so let's say if I have to simulate that the sound is coming from left and not right. So I have a speaker here. Okay, so sound coming from left, right? So this is my left. I don't know how it's looking there, but this is my left. So left speaker, I'll play the sound, and right, I'll not play the sound. And where's the sound coming from in my perspective now? Left. Okay, because here it's playing and here there's no sound. If I have to somehow make it in the middle, how it should sound like? Left and right playing same intensity. Okay, now the sound is coming from middle. If I have to play from right, not from left, the left will stop and the right will play sound. Okay, so that's how the sound is coming from right. And pick any direction in this world. So let's say in 360 area, pick any direction from there. So I can compute a exact number that how much intensity of this speaker and how much intensity of this speaker to appear that the sound is coming from there. So it's a very simple algorithm relatively, but because of this, we create the illusion of surround sound.
Okay, sir. Thank you. So, is there anyone want to ask? Okay, sir. So, can we go for the conclusion of the session?
For sure, sir. Would be honor.
So, on such a short notice, you have conducted this session, and we have not met anywhere. We have just communicated with online website, and with my one message, you have given your valuable time to our students regarding the STEAM technology or the immersive technology, I can say, augmented reality or virtual reality. I can surely tell your session has given the basic impact and basic knowledge about the AR and the VR and how it works. Like you have explained the 3D visuals also in the Maya, the 3D object. I can see means how I can see that 3D over 3D object left, right, and center. These all the points will help to my students to learn this technology further and to make a career in this technology. So thank you so much, sir, for your valuable time. But I want right now you have conducted the online session, but I request I want your time from your busy schedule. You please come to our college and give a physical means offline session to our students. They like it more. Thank you so much. So here I can announce that session is over. Thank you so much, sir.